Hi, Mark here with My Engineering, and today I'm excited to show you the latest updated version of our Flange Vision software. We have some ongoing field trials going on with the software right now that we're getting some very good feedback on how to make a few changes that will make it a little bit more practical for the technicians in the field, as well as improving the deliverable at the end, so having that report that is absolutely fit for purpose. So let's jump right in and take a look at the software. So the first page that we're going to look at is the opening page when you open up the software, and this is the import page where you would start a new inspection. There is different structures that we have set up. You can see here on the left-hand side of the screen that gives you different configurations to help you pick the points that you're going to use for the inspection. So the standard one obviously is going to be circular, so a standard flange would fit into that category. What it's going to ask you to do is pick your 12 o'clock position and then 3 other points on the sealing surface or the gasket face. We also have a rectangular option. So if you had some kind of I guess similar to like a ducting or a rectangular face, any kind of a sealing surface, you could even do on like a cylinder head, something like that. That would be appropriate. And then irregular is the third option. So this is where it'll give you the option to select all of your data points that you're going to pick. And this might be very appropriate for something like an exchanger on the head side where you have the partition going across. If that partition is on the same plane as the gasket face, then you may want to select points along that partition in order to get the same data all the way across. So a circular may not fit that sort of scenario if you need to get data points that are not on only the outside round sealing surface. Right below that, you have 2 options for raised face and flat face, and so this is going to help the software decide what kind of configuration for the inspection. At this current version of the software, this actually doesn't do anything because in this center box here, this will be there's 3 options for how you actually perform the inspection. You have flatness measurement. That's obviously the core function of this software, so we're going to be doing that one. And there's 2 other options that will be coming out in a future iteration of the software. So you'll be able to have thickness measurement, which is going to give you the overall thickness of the flange, and then raised face thickness. So you'll actually be able to measure the height of the raised face off of the bolting face of the flange. So that would be helpful in criteria on if the flange face itself does not meet your criteria for flatness and you have to do a field machining on it, you need to know the height of the raised face in order to determine if it's if you have enough material left in order to actually machine it. So there is data sections for this that will be manual entry, and we'll get to that shortly here. The last box here that we need to look at is obviously just the import data field. So we're going to import our flange data. So this will be an ASC file, a laser point file. And all you'd have to do is specify if it was scanned, not what you want to do the measurements in, but if it was scanned in either metric or imperial. The scanners that we use default to metric, so we're going to be using that. So if we want to import data, I'm just going to use a 12-inch flange here. And so this is one that we already had scanned, and it was going to be refaced. So we got 2 scans of this one actually. Now we're looking at the analysis side. So this is where you want to pick your data points. So this was scanned with a handheld scanner. There is no, I guess, coordinate system that was attached to it. It doesn't know which side is up. And you can actually see, because this was on a tabletop, so the table is kind of floating off at a weird angle in space here. So 12 o'clock position is actually all the way down here. I'm just going to move this little picture of myself talking here. There is an option here for number of points. So you can choose how many points you want your inspection to entail. If you're doing, say, a 1-inch flange, perhaps your procedures will want it to be a 4-point inspection where you just have the cardinal points. You might use an 8-point inspection. Maybe standard is a 16-point inspection or a 32-point inspection. You can pick whatever number of points you want. Let's just say we want a 12-point inspection for this one. Now what it is going to ask us to do here is first select the 12 o'clock position. So this will be the default first point in our whole inspection. And so if we can see our table is here, I know that my 12 o'clock position is going to be here, so I'm just going to select 1 point on the gasket face. Now we have to select 3 more points, and what that's going to do is going to give the software the data it needs to build a circle that it will place all the points on. So these points that I'm selecting are not going to be used in the actual inspection. It's just going to create the circle where it draws evenly spaced points all the way around the gasket face here. So I'm going to pick one just in every cardinal direction, just to give it a good data, sort of right in the center of the face itself here, or the gasket face. And now it has selected our points, and it kind of gives you a preview roughly on what the highs and lows of this flange are. This one was actually remarkably flat. It just needed to be refaced because it didn't have the little grooves cut into it. It was actually, someone had polished it flat for reasons that we'll never really know. But so you can tell that it actually does look fairly flat, but we're going to do this inspection anyway. Continue to export is our next button, and that will take us into this screen. This is where we actually build our report. So you do have the preview of the flange here. It will orientate the 12 o'clock position that we chose at the top, and then you have your data points right underneath it here. So 1 through 12, we have a 12-point inspection is what we chose to do. And you'll see your deviation. I have it set in the settings. It's measuring it in inches, so that is probably what most people are going to be doing if they're doing flanges, at least in North America. That is kind of the standard system that we're working in. And so you can see all of our deviations. Our 12 o'clock position is by default our 0 position. You can change this to whatever kind of suits your procedures. So let's say you want all the numbers to be positive, so you want your lowest elevation to be your 0 point. So in this case, it would be our point number 8. We can select that as set for 0. And now all of our numbers are positive, and position 8, this guy right here, is going to be our new 0. Now, to set up the actual report on the right-hand side here, it allows you to put in all sorts of data that you want on the report. So you could have the name of the inspection project that you're working on, if you want to have it for turnaround 2025 Q2, something like that. The client that you're working for, the location, so this might be the unit it's in, your supervisor, job number. So good details for the job to help identify it. The equipment used, so this would be the scanner. In this case, we used a Scantex SimScan 42, and the serial number for that. So this is part of the quality tracking. And then you're going to have the flange ID, PN ID, the size, class, line number, material number. I'm just going to move this over here again. So now you're identifying, I guess, for the flange information here. Underneath that, you're going to have surface finish. This is a manual entry, so it's going to be a checkbox, so you can say the surface finish in the cardinal directions, if it's kind of pass, fail, if it's really pitted, if it's damaged for some reason. So you'll give it a check mark if the technician in the field says it's good. Then there is, at this point, this is still a manual entry. It will be a little more automated in the future, but you'll have, with your depth gauge, you can do the raised face height and then the flange overall thickness. So you can manually enter that. And then, of course, notes would be the last one. So you could just say flange overall corroded or in good condition, whatever notes that you may want to include in the report. And then we hit export. And so finally, now we have the report that is the exportable, the deliverable that you're going to be getting out of the software. And so there's a little bit of customization you can have in here. So you can have your own company logo, your company name, obviously, and then the operator who's actually doing the inspection. So that's all important information that you kind of have to have included. And this is all the information that we put in on the last screen here. So you have your flange ID, all the information on the actual flange that you're inspecting. Here is your results from the measured off the flange. And then all the other little things that we have here. So surface finish verified, yes, yes, yes. Okay, we thought it was all good. Your raised face and your flange thickness. And then, of course, notes and that kind of thing. So you have a complete report. So this would be the perfect solution, replacing having the pen and paper in a field, having the dial indicator, or whatever means you're going to be trying to do the flange flatness check out in the field. We're able to do it all. And this, as you can see, takes a matter of minutes to actually set up. So the scanning, only a couple of minutes per flange when you're using a blue light laser scanner, so you have the accuracy, but also the speed, and then setting up the reports and having a final PDF deliverable with all the information you'll require is just a few clicks. So that is a quick look at the Flange Vision workflow. So as we just did a round 12-inch flange, it doesn't really matter if we're going to be doing round, square, or an irregular shape where we pick our own points at random. It doesn't matter if we're going to be doing a 1-inch flange, a 12-inch flange, or a 100-foot flange. The way the software works is always the same. So the data that you bring in determines the accuracy. And when we're using, as we did in this example here, a Scantech blue light scanner, your accuracy is going to be exceptionally good. If you have any other questions that weren't answered in this video specifically, you can always reach out to us, support@myeng.ca, or you can leave a comment in the comment section below. If you'd like to get a demonstration to see how this would work for your company specifically, we can always set that up. We're always happy to accommodate. Thank you guys for watching, and make sure you like and subscribe so you can get all future updates on Flange Vision and see our other videos for workflows that might also help you out.